All right, everybody. Let's go and get going. It's my great honor to introduce Remi here. He's going to talk to us about type-safe queries, and take it away.
Hey everyone. Don't worry, this talk should be reasonably fast and you'll be able to get lunch very soon. So I want to talk to you about type-safe query today. More specifically, I'm going to introduce a package called Cloud Firestore ODM. It's a package made in collaboration with Google. It's a side package to Flutter Fire for Firestore. So just for a quick reminder, when you use Firestore, by default, the syntax is as follows. You usually typically make a stream builder, and then as stream you pass your query. So Firebase Firestore.instance.collection, like say users, something like this, to where or order by, whatever. And then you call snapshots, and then you have a builder which takes the data and rebuild whenever that data updates. By the way, there is a small mistake that you might have seen. Instead of the text, it should be a list view because we have a list of documents, not just a single document. And you'll see this on every side, so forget about it. But anyway, yeah, that's how you typically use Firestore. But there are some small issues, small inconveniences, in my opinion, with this API. First, you might see that we are using effectively untyped objects. We have maps, and so we have to read properties using using strings on the map, and then maybe cast the result if it's an integer or a timestamp if you want to read specific content. So obviously you could make a typo on one of the properties. If you rename a property, it might get tedious to rename it everywhere. You have to do the same thing on query side. The parameters was stored on the backend too. And last but not least, you also have to, when you do certain queries, like a where operation, the type of the value passed is dependent on what's on the document. So like here we are doing a where operation on the first name, so it has to be a string. But you could, for example, pass a Boolean or an integer. It would still technically work. Obviously, you would find nothing, but it would technically work. Okay, and then another fact is that we have to call that .snapshot at the end. It's not a big issue, but what that effectively means is that whenever the widget that creates the stream builder rebuilds, you'll call .snapshot again, which creates a new stream. And so for a few frames, if you're listening to maybe connection state on the stream builder to see if there is a progress, whenever the stream rebuilds, you'll get a small refresh in a way. So it's not as efficient as it could be. So one solution in Firestore to go slightly deeper is to use something called with converter. You might not be aware of it, so I'm going to show it here too. Effectively, what we should do is we move the logic for defining our collection slightly outside of the widget. We define typically a top-level variable with our collection, and then we call .withConverter, and that withConverter is supposed to handle encoding and decoding for specific documents to convert them into maybe a class or something else. Here I'm using a record, which is a Dart refuser, because I didn't want to define a class, but you could use a normal class. So we have those from Firestore into Firestore objects, which receive that map object, convert it into something more Dart-like, or maybe do the opposite, like with toFirestore, we encode that class and into a map. What this changes is that now inside our stream builder, we can use our previously defined collection. We can call where again, and then inside our builder, now we just read the property instead of doing a map access. So that's nice. We don't have a map anymore, but we still have the issue with untyped queries. The first, when we do a where query, we still have to specify the string first name, and the is equal to is still untyped too. We could still pass a Boolean. And we also still have this start snapshot. So that's where I'm going to introduce Cloud Firestore ODM. It's basically doing a slight tweak on this again by using code generation. And I know some of you don't like code generation. You know I like it. Yay! Kevin validates. Especially considering I'm using his package, actually, in Cloud Firestore ODM. So Cloud Firestore ODM is built on top of JSON serializable and Flutter. It's combining both to do a bunch of extra stuff for you. So basically, when you want to define a collection, you define your typical model, like here I have a user with a name and an age. You annotate it with a specific annotation, which we'll cover in this next slide. And then you define a top-level variable representing your collection, which we will later use to read the content of your collection. And you annotate that with @collection. You specify the type of your object and the path to the collection. So here it's just user, but you could have slash in here if you wanted to. So that user class needs to be serializable. We need to have a way to convert it into a map and decode it from a map. Hence why we have this Firestore serializable annotation. And that annotation is actually this one, which is something you need to define in your project. It's not imported. It's not exported by the ODM, because you might want to change some fields on that annotation if necessary. So what basically is just an alias on the JSON serializable annotation, but with extra flags enabled, like create field map and perfect tool legend, which are necessary for the ODM to work. And then we pass these converters, which is Firestore JSON converters, which is something from the ODM. That variable is what's necessary for timestamps and geopoints to work. This will enable your models to decode those type of objects. All right. So now that we defined a collection, we can now, inside our stream builder, well, not a stream builder anymore, do collections. So as you can see, we're not doing a stream builder anymore. We are doing a Firestore builder, which is taking ref as objects. That ref is coming from the ODM. It's a type of, basically a query. And as you might have noticed, now the result is the object, the user we defined previously. So we can just do data.age to access the user's age if we wanted to. But also, we now get extra superpowers when we do our queries. We no longer have to do where and we pass the string name. Instead, we have one specific method generated for every field of your object. So if there is a property name on your user object, you can do where name directly. And the bonus point is that with this where name, the parameters are also typed. So like if you want to pass is equal to, then if you try to pass a Boolean, you'll get a compilation error because the ODM knows that it's expecting a string. As another bonus point, it's not just reading that's typed, it's also setting operations. So like if, for example, you wanted to do an update, you could do your update with a set as usual and pass a user object, which works with converter 2. But using the ODM, you can do the actual update method. And you can pass, for example, age here. Instead of having to pass a map, and in the map you pass the string age and the value, you can just pass the property age. And again, it's fully typed, so if you try to pass something that's not an integer, you will get a computation error. And I included this slide twice. It's a very important one. All right. And last but not least, we can define subcollections. Because one of the issues when you try to use with converter is that it works fine for collections that are at the root of your model. But if you want to define a collection within another collection, it gets weird because you now have to use with converter inside your build method directly, because you cannot because you need you're dependent on likely the ID of the document you want to currently access. So the syntax for this in the ODM is actually when you define your user reference collection, you can also specify a second annotation, a second @collection for sub-collections in here, and you specify the path to it. So like here it's users and star because it's just a random ID, we don't necessarily know about that ID. And then the name of the sub-collection. And then now I can define two different models, one for the user and one for the sub-collection. So here it's an address, which now enables us to, inside our main or widgets, or you could still use Firestore Builder if you wanted to. We could do, for a specific document, for a specific user, we can now access this .address property. So that enables us to directly read content of the sub-collection, and it's also fully typed, so we can do .address, .where city is equal to Paris. So that's pretty much it for me. As I said, it was quite fast. So in conclusion, as you can see, at every point of the API, we now have a fully typed API. So if you somehow rename a property, you should see all the potential places where that needs to be renamed. But still, it's still quite similar to the default syntax. Like you still have your where, and it's just that instead of where and you pass a string name, you just do where name. There are some subtle differences, like for the start at queries. You have to pass the start at on the order by, but overall, it should be fairly familiar if you've used Flutter before. And yeah, I know that people don't like comparison, so it's worth mentioning, but hopefully it should be better soon once we have metaprogramming. Macros. Yeah. So that's it for me. Thank you.